Okay, we'll get started. In this video we're going to be looking at 2b, which is xt graphs, or at least the first part of xt graphs. So the first idea in this section is that an object's position over time can be represented on a position time graph. Or, for short, we call it an xt graph. So this is a position time graph actually over here. So what this is for, if you had an object, let's say you had a car, and it was moving, you could describe that motion in words, but you could also basically plot that motion on a graph like this, and this would actually tell you a lot of information very quickly about how that thing is moving. So a couple things when you're looking at a position time graph. The vertical axis, right here, this is the vertical axis, this one, that's the position axis. And because the variable for position is x, right, it's going to have the x on the vertical axis. The other axis is over here. That's the time axis, the t-axis. So the standard, right, you remember the standard unit for position is going to be meters. The standard metric unit for time, as seen on this graph, the standard unit for time is going to be seconds. When you look at this graph, there's a couple things, and a lot of them have to do with the slope. So for example, if you have a positive slope, that means the object is moving in a positive direction. So like right here on the graph, draw that, right here on the graph, this is a positive slope right here. So again, it's not clear what direction that is. It could be up, it could be to the right, it could be east, but it's a positive direction. So again, if you have a positive slope, it means you have a positive direction. And the opposite's also true. If you have a negative slope, you're going to move in a negative direction. So over here, this is a negative slope. So again, this is going to indicate that that object's moving in a negative direction. Now, depending on the situation, that could be down, or it could be to the left, or it could be west, but a negative direction is what it's going to be moving if you see a negative slope like this. And the last thing, kind of with at least the direction of the slope, if you have a zero slope, that means it stops. So up here, this level part, the object's actually not moving. And it makes sense, because what's happening is time is going forward as you go to the right, and the position's really not changing. So that means the object's really just stopped, it's standing still. So that's some of the important stuff with slope. There's going to be one more thing though as well. So I'm sure you've heard this word, speed. Speed is a measure of how fast an object changes its position. So again, if it's changing its position quickly, it's going to have a high speed. If it's changing its position a little slowly, it's going to have a lower speed. And this actually appears on the graph, speed. So the steeper the slope, the faster the object is moving, or the greater its speed. So let's take a look. Right, this part of the graph is pretty steep. So this first section of the graph, that object, whatever it is going to be moving faster than over here. Right? It's still definitely moving on this side, but it's a little more gradual. So again, if you have a steep slope like over here, that means that you're moving faster. If you have a more gradual slope, that means you're moving slower. And again, if you're level, you're technically not moving at all. So that's important to keep in mind about speed. The units for speed, or the standard units for speed, are going to be meters per second, m divided by s. There's other ways to measure speed, but that would be the standard metric unit that we're going to be using. And last thing, it's important to keep in mind that when we look at graphs like this, like the one up here, that have like nice curves and nice straight lines, that's not always going to be true in real life. So real-life graphs or experimental graphs that you get from actually setting up an experiment and taking data are going to have bumps. And again, the theoretical are going to be nice, neat-looking graphs, but this might be an example of what you get from an experimental graph if you actually hooked up equipment and generated your own XT graph. So again, you see it's kind of bumpy, it's not quite as straight or as neat of curve as you'd see in like a graph like above it. But that's not, again, there's not necessarily something wrong. It's just that in real life, motion's not going to be super perfect, right? The object is, moving back and forth a little bit. It's not moving in a clear way. It's maybe stopping like really briefly or something. All this stuff kind of adds up, and you're going to get motion that doesn't look as neat. It's going to be kind of jagged looking. But the important thing to keep in mind is that even if motion looks like this, there's still an underlying trend. So like if this is your experimentals, if this is what you got for data, you can still see that there is an underlying trend to this. That even though it's kind of jagged, you can still see there's a general kind of best fit line of a diagonal going through that. So that's just something to keep in mind, because you won't always see, in the real world, super neat graphs. So a lot of times they'll have little bumps to them. So those are really all of the important things for XT graphs, at least for now. So, what does it represent? What does slope say about the XT graph? And then what does steepness say about it? So let's actually see this in a problem dealing with XT graphs. So here's a problem. So before I go through it, make sure you take some time to solve it. So again, you're solving it out first before I go through the answer. Okay, now let's go through it. So it says sketch an XT graph. One second. Sketch an XT graph for the following. A squirrel runs quickly to the west, then stops for a few seconds, and then walks slowly to the east. So quickly to the west, stops, and then walks slowly to the east. And we need an XT graph for this. So this is what's really happening. I will represent the squirrel with a box. So this squirrel is going quickly to the west, right? Just in case you forgot your compass. Right, north, south, east, west, is moving quickly to the west, right, quickly, and then stops. So then the squirrel's going to stop, and then it's moving slowly to the east. So it's moving, not as much, but to the east instead. Let's exaggerate that quick motion a little bit more. So that's what's happening. Those are 3 parts to motion. Part 1, Part 2, and Part 3. So we need an XT graph for this. So first thing we're going to do is we're going to sketch out the grid. Sketching, arrow, arrow. This is going to be the x-axis, the position. It's going to be the t-axis, the time axis. So the first thing that's happening is it's moving quickly to the west. So quickly means that it's going to be pretty steep. West means that it has to be, that's a negative direction, so it's going to be a negative slope. So the first part of the motion's going to be a diagonal line. I'm actually going to use the line tool to make this neat. So it's going to quickly, it's pretty steep, and it's moving to the west. That's a negative, so it'll look like that. That's the first thing. Second thing, slowly, that means that it's stopped, so it's pretty much level for a few seconds, so we'll draw it kind of short. Like that. That's the second part of the motion. And the third part of the motion is slowly to the east. So east is a positive direction, and slowly, that's going to mean that it's moving, but this slope's going to be a little more gradual. So the last part, so it's moving to the east, it's moving in a positive direction, but it's way more gradual. So we'll draw it like that. And there we go. So again, that's what the motion would look like. And again, just a note, you don't have to make it super neat. This is kind of just a rough sketch. But very important to make sure all the parts of the motion are there. So part 1, part 2 down here, the level part, and part 3 over here. So that's the motion of that squirrel, all 3 parts of it. So make sure you have the notes down, make sure you have this problem down, and that's it for now.